Okie doke, again, I'm going to combine example 9 and 10 together. They're very similar. We're asked to graph both of these. Remember, whenever you're working with these logs, you're able to change them to exponentials using the cycle, that number 1, right? So essentially, whenever you have one log and an equal sign, we can do the cycle a raised to the y is equal to x. So we're going to do that here. So if you want, you can change the order of it and write it like that. So now it's going to be 5 raised to the y is equal to x. So 5 raised to the y is equal to x. Okay, and now that's in a form that we are used to. So essentially, we can make our t-chart just like we did on example 1 and go from there. It would be easier to plug in values for our y because then it'll spit out the x. So we can do the same thing that we have been doing. -2, -1, 0, 1, and 2, right? So if I plug in 0, we always get 1. If I plug in 1, 5 to the 1 gives me 5, which means 5 to the -1 is going to be 1 over -5. If I plug in 2, 5 squared is 25, which means this is going to be 1 over 25. So now, whenever we graph this, it's always going to be at that intercept, 1, 0, and then it's going to make this type of shape, okay? So, yeah, perfect. Cool. And now for example 10, honestly, you really could just use your calculator. So this g of x is a fancy way of saying y, right? So we have natural log x. We can make our t-chart, x, y, and again we can do -2, -1, 0, 1, and 2. And we're plugging in values for our x, so we can just use our calculator and do natural log -2. Oop, error. Oops, oh, why is it an error? Again, remember, we can't have any negative values for our x's. Sorry, so that was bad on my part. And we actually can't have our 0 either. So it can start at 1 and go up. So let me do that again, my bad. A little brain fart on my part. So yeah, if you ever get a error in calculator, doesn't mean that you're doing it wrong. It just means that it might not exist, okay? So we'll do natural log of 1, which we should know is 0. Okay, and then we can do natural log of 2. Ooh. Natural log of 2, which gives us 0.69. We can do natural log of 3, which gives us 1.09, and essentially you can graph this and see what you get. So we have our this. Remember, so we have our 1, 0. We have 2 and like 0.6. We have 2 and 0.6. We have 3 and like just above 1. So essentially we have something like this. Remember, we can't go past 0, but you could do like a number smaller than 1. So you could do like a half if you wanted to, or 0.5. And if you plug that in your calculator, you get -0.69. So if you do a half, that would be like here. So essentially, their graph is going to look very similar to example 9, okay? So whenever you're working with these logs, whether it be the common log or the natural log, it's always going to be in this shape. Whenever you're working with the exponentials, it's always going to be in that E shape, unless your A is in between 0 and 1, right? And then it's going to flip over your y-axis.